Okay, so now why we use honorary square? Um, so there are three reasons here given here. The first one, because honorary square is relatively easy to use because just now I explained to you that we just need to find the baseline to represent the what we call that the relationship between y and x. And the second one, the goal of minimizing sum squared of error is appropriate from a theoretical point. So just now I explained to you that why we minimize sum squared of error, not the sum of error, because it's possible that positive will cancel out negative error. But another thing that I haven't mentioned to you that we want to minimize the error because we would like to have our prediction to be what we call that to be accurate as possible. So so that if the estimate, our prediction close to the value of actual value of y, meaning that our error must be a small value. So that's why we want to minimize the error. But of course, in this case, we cannot minimize the sum of error because positive canceling will cancel out negative error, so that we what we call the finite line that gives us the smallest value or the sum squared of error. So by minimizing the sum of squared errors. And then the last one, on the least square estimator have a number of useful properties. For example, that one of the useful properties is that the estimator of honorary least square are unbiased estimator. Unbiased means if you take the average of all possible estimate of the parameter from the sample, then the average is equal to the true value of parameter, the one that just now I mentioned, the true value of parameter, beta 0, beta 1 is unknown. But if the estimator is unbiased, so if we take the average, so from different samples, we can get different estimate of beta 0 and estimate of beta 1. But if we take the average of all possible estimate from different samples, then if the estimator is unbiased, then the value of the average of the estimates are exactly the same, what we call the equal to the true value of the parameters. So we call that kind of estimator as unbiased estimator. So in this case, if we specify all the assumption or requirement for the model to be valid, to be a valid model, then estimators, the honorary least square estimators are an unbiased estimator. So they're one of the useful properties of the honorary least square estimators. So the next step that you need to do to interpret the result, the estimation result. So check the sign after you estimate, check the sign of the coefficient against the expression as the hypothesized, or what we call as a priori expectation, our prior expectation regarding the relationship between y and x. So for example, the given example, do we expect a positive relationship between average grade of pre-university studies and the CGPA at the university level, and then check the magnitude. So check the magnitude of the coefficient against the expected value if there is. So do we have prior expectation with respect to the magnitude of the grade at pre-university level towards CGPA at the university level? The next step is to perform diagnostic analysis in order to know or to determine whether we use the correct specification of the model. So is the model specification correct? So meaning that whether all the, for example, whether we use the correct what we call that independent variable or SMH variable in the model. So that's what we call as model specification correct or not. So and then is the functional form correct? So if possible that, I mean, we can use different functional form. For example, so in the given example, we use linear equation, but it's also possible that we can use the ratio between y and x given by non-linear. For example, the quadratic equation or function. So you need to perform a test to identify whether you use the correct functional form or not. So in the following lecture, we will discuss how to perform this test, how to perform the specification error, and for example, how to know whether we use the correct functional form or not. And then is there any omitted variables, important variable that you did not include in the model? Okay, so we also can use the test to identify this one, or to get idea whether we do have other important variable haven't included in the model, or is there any irrelevant variable we include in the model? So the variable x which is not important but we include in the model. So that also can be or can be. I mean, we also can determine that one. So how later on we discuss. And then is the regression spurious as the result of possible problems of autocorrelation, heteroscedasticity, and multicollinearity? So there are three different problems, possible problems that normally occur when we construct or we build an econometric model. And then is the error term randomly distributed? So you need to make sure that, because just now I mentioned that the prediction error, that it must be something random. Okay, so you need to make sure that it's randomly distributed. So you need to check the distribution of the estimated error, whether it is randomly distributed or not. And then does the error term correlate with other independent variables? Because we don't want to have, I mean, that's one of the requirement. You cannot have correlation between error and the independent variable, any of the independent variables X in the model. Are the values of error term independently and identically distributed with zero mean and constant variance? Okay, so so you need to test the distribution for the error term. So it's quite similar to what we call that this one. But you need to also make sure that the average is equal to 0, and then it has constant variance. So that it is homoscedastic. It's not heteroscedastic error. The next step is to perform hypothesis testing. So if the model specify all these diagnostic checking on the model as well as residuals, and then you can use, I mean, let's say the model pass off this diagnostic checking, and then you can use the model to perform hypothesis testing. So in order to answer that, is the question, is the estimation statistically significant or meaningful? Whether I mean the relationship between y and h of x is significant. Okay, so does the result match with economic theory? Okay, and if not, if there are any possible explanation, then should I or should you add another variable to the model and re-estimate? Okay, so so within this what we call the stage, you need to decide on this, or to perform, or to determine, or to inspect each of these. And then the last one, stage 8, to perform prediction. So you can use the model to do prediction. So for given value of x, what is the prediction of value of for the value of y? So an example, predict the level of achievement at university level for a given level of a average grade at pre-university level. And then from there, you can answer the question, is there any policy implication on this? So for example, let's say based on the model, it suggests that those obtain CGPA at pre-university level lower than 2.5, we predict them to have what we call that, okay, let's say less than 3 CGPA is going to, we predict them to have CGPA at the university level to be lower than 3 as well. So that based on our model, it suggests that those with CGPA at pre-university level lower than 3, we predict them to have CGPA at the university level to be lower than 3 as well. So from that finding, then you can come up with a policy implication, or what we call a suggestion on how, for example, you can introduce or to suggest to do the intervention, what we call that measure, in order to help those students maybe to can, I mean, for example, to give what we call that more attention or special treatment for what we call those student, so that they can get a better CGPA at university level. Although based on prediction, then we predict them to have to achieve lower than 3 GPA. Okay, so that's how we can use the result of econometric analysis to come out with what we call that with policy recommendation, for example.